the Pure Maths 1 and it's exercise 8C. This is our second episode on this exercise. The topic of the exercise is the maximum and minimum problems, and we have already done one episode on this, and this is our second episode on this. This is basically A levels mathematics and 9709. The course we are doing is related with this paper 1. So basically we are solving the course book, the paper 1, Pure Maths 1. So let's start today's exercise. So we have this exercise, and the question number 4 is showing up on your screen. So we are starting from the question 4. The diagram shows a rectangle ABCD where the AB is 20 centimeter and BC is 16 centimeter, and the PQRS is a quadrilateral where the PB equals to AS equals to 2x centimeter, BQ is centimeter, DR is 4x centimeter. Express the area of the PQRS in the terms of x. Okay, so let me show you the question. The question number 4. This is the question which we are talking about. Question number 4. And this is the diagram. Okay. So here, this is given that this is 2x, this side is 20. So this portion will be 20 minus x. This is given to me that the BC is 16. This side x is given, so this side will be 16 minus x. I know this whole thing is 20. So if this portion is 4x, then this portion will be 20 minus 4x. I know this whole thing is 16. So if this portion is 2x, then this portion will be 16 minus 2x. Their A part is that we have to express the area of the PQRS in the terms of x. This shaded area we have to find out. So the method is very simple. You find the area of this whole rectangle. From that, subtract the area of this right angle triangle, this right angle triangle, this right angle triangle, and this right angle triangle. So they are right angle triangles. You subtract their area from the area of the rectangle. So you will get the area of this quadrilateral PQRS. This is the A part in which they ask us to find the area of the PQRS in terms of the x. Okay. So let me do this. The area of the PQRS will be equals to the, let me first of all find the area 1. That will be length into the width, and that will be 20 into the 16. That will be 32 centimeter square. Okay, 320. 20 multiplies 16. That's the area of the big rectangle. Okay. Now they ask us to find the area of this quadrilateral. For this, let me say this is area 1, area 2. This is area number 3. This is area number 4. This is area number 5. Okay. So we'll find out the area of the area number 2, which is the right angle triangle. Area number 2, that will be equals to 1 by 2 into the base is 2x and the height is x. Okay. So the area will be only x square. So the area 2. Then I will find the area number 3, which is also a right angle, and its base is 20 minus 2x, height is 2x. Talking about this. So it will be 1 by 2 into 2x into 20 minus 2x. So 2 cancel, so it will be 20x minus 2x square. Then I will find the area number 4. Area number 4 is this right angle triangle. Suppose if this is your base 16 minus 2x, then this will be the height of that triangle. So it will be 1 by 2 into the 4x into the 16 minus 2x. Okay. So the area 4 will be equal to 2x into the 16 minus 2x. So it will be 32x minus 4x square. Then I will find the area 5. Area 5 is also a right angle triangle, and the area 5 will be equals to 1 by 2 into the 16 minus x minus 4x into 16 minus x. Okay, so this will be 10 minus 2x into 16 minus x. Okay, so I can further simplify this. We can further simplify that. Okay, so if I will multiply both these brackets, I will have so this one will be, it will be, you see, this will be 160 minus 10x minus 32x plus 2x square. So this will be 160. This will become 42x plus 2x square. Now the area of the PQRS will be equals to the area 1 minus the area 2 uh, minus the area 3 minus the area 4. Area 1 is 320, then you have minus, and it will be then area 2 is x square minus, here you put bracket 32x minus 4x square, and then you have again minus, then you have 160 minus 42x plus 2x and square. So this will be, I can write it here. Okay, so the area of PQRS will be equals to, you see, it's a huge expression. Okay, so we will have area 1, that is 320, then you will have minus x square, okay, minus 32x, then you will have plus 4x square, then you have minus 160, then you will have plus 42x, then you will have minus 2x square. Okay, so the area will become equals to how much 4x square minus 2 minus, you are left with the 3x square. So you are left with the 3x square minus 32 plus 42, 8 and 2. So this is plus 10x. Okay, then you will have 320 minus 160. So you are left with the plus 160. So area seems to be 5x square. We are doing which question? Question number 3x square minus 10x plus 160. Minus 10. They say minus 10x square. Why? Minus. So this becomes plus. Their answer is that in the book the answer is 3x square minus 10x. Our is plus 10x and plus 160. Plus 160, but this 10 has a negative sign. So let me check again. Okay. So we made some mistake. 320. Okay, that's right. So let me check this, sir. Okay. So this will become 2 cancel x here. 2x into x. Okay. This is 1 by 2 into 2x minus 20 minus 2x. 2 cancel. So x will multiply 20x minus 2x here. This I think is right. This is right. This looks right. This is 2x and 4x into 16. Okay. So you're left with 2x multiplied with the 16, 32x minus and 4x here. This looks good to me. Okay, this is 10 minus 2x. Okay, now these are multiplying. This is area number 5, 20 minus 4x, M16 minus S, okay. So this will be 160 and this will be minus 10x. This will be minus 320. This 32x, sorry. This will be minus plus 2x here. Okay, this is 160. This will become minus 42x. This will become plus 2x here. So from that total area, I will subtract the area number 2, area number 3, area number 4, and area number 5 also. So how many? I so this area 1, then area 2. Oh yeah, I have not written the area number 3 here. Yes, so area number 3 is also here. So you have to minus 20x minus 2x here. I have not written the area number 3, so this, okay? Now, okay. So here you will have minus 20x, okay, and plus 4x square, okay. Now what will happen? We will have 4x square, 4x square. This is 8 minus, this is 320 minus x square minus 32x minus 4x square, okay, minus 142x plus 2x square minus this one also 20x minus 2x, okay. So you will have 320 minus x square minus 320x plus 4x square. Then you will have minus 160 plus 42x and 42x, okay, and minus 2x square. Then you will have minus 20x, and then you will have minus, sorry, why not here? This is 2x square. Okay, so 2x square. Okay, now let's see what happens. This is 2 and 4. 6 minus 2. This cancels, so 4 minus, and that's right. Okay, now you will have minus 32x plus 42, that will be positive 10, and you have to subtract that. You 30 plus 42, that's plus 10, minus 20, so you will have minus 10. Okay. You see, even what happened? Actually, see what happened. I forgot to write the A3 value. Okay. So now it's good. It's good now. This is good. Okay, sorry. My bad. Okay. Now it's good. You see, when we work online, we are working live, so it's possible that we might miss some calculation. And okay, the A part is done, G. Now in the B part, he says, given that x can vary, find the value of the x for which the area of the PQRS is a minimum, and find the magnitude of this minimum area. Okay. Now, if you want to find out the minimum area, so that you know the area is equal to of that thing, 3x square minus 10x plus 160. So first of all, I have to find the derivative. Okay, so that will be 6x minus 10 plus 0. So at the stationary point, what will happen at the stationary point? The dA by the dx will be equal to 0. So 6x minus 10 is equal to 0. So x will be equal to 10 divided by 6. So x will be equal to 5 by 3. Okay. Now I will find the second derivative, d square a by the dx square. And that is, first of all, let me write that, 6x minus 10. So you will have d square a by the dx square, and that will be equal to 6, which is positive. So at x is equal to 5 by 3, area will be minimum. Now I have to find out that area. So area is equals to 3x square minus 10x plus 16. So the area will be equals to 3 into 5 by 3 square minus 10 into 5 by 3 plus 16. So let me use my calculator. So where is my calculator? Oh God. Where is my calculator? Okay, I got my calculator. Okay, so it is we have 3 multiplier bracket 5 by 5 divided by 3 bracket close square. Then you have minus 10 bracket start 5 divided by 3 bracket close plus 16 equals to, this is 7.66666. So it will be basically the maximum area, the minimum area will be 7.67 centimeters square, you can say. Let me check first of all the answer. We are doing question number 4. Their answer is 1. Where did I put that value? Okay, let me do it again. What's the formula for the area of that? That is 3x square minus 10x plus 160. Sorry, this is, I wrote 16 here. Okay, so I am missing the numbers again. Let me write it. 3 multiply bracket start 5 by 3 bracket close square minus 10 multiply bracket start 5 divided by 3 bracket close plus 160 equals to 151. This is what the answers are. 151.67. Okay, so 151.67 is the right answer, sir. At the x equals to 3 by 5, you will get the minimum value of the area. So this is how you will do the question number 4. You see, today while I was doing this question, 2 times a mistake happened. You see, they're very important to learn from your mistake. You see, when I was finding the area of the PQRS, I wrote the right formula A1 minus A2 minus A3 minus A4 minus A5. But what happened when I was writing it, I forgot to put the value of the A3 there. So then I wrote that A3 value at the end. So that was the A part. We found the area, that is 3x square minus 10x plus 16. So then he asked us to find the minimum value of the A. So first of all, I derivated the A with respect to the x, dA by dx. We found it 6x minus 10. Then I, at the stationary point, you know the dA by dx will be 0. From there, I got the value of the x. Then I found the second derivative. Its answer directly is 6, which is positive. So it means that 5 by 3 x value, the A will be minimum. So then I, in the formula of the area of the PQRS, I put the x equals to 5 by 3. And then again, by mistake, instead of writing 160 at the end of that thing, I by mistake wrote 16 only. So then we corrected it, and so we put the values, and then now the answer is good. There is no problem. You see, the mistake is normal thing. It's not a problem, because you see, when you're working, if you are distracted, my son was here, my youngest son. So I was getting distracted. So that's why. Or I'm just got distracted, my focus gets out, then automatically you make a mistake. So this is how you do the question number 4 of this exercise. I hope you all understand this. And let's go to the next question. The next question of this exercise is the question number 5. Okay, so let me first of all erase this whole thing, and then we will go to the next question. So question number, We are going to do the question number, the next question. And the next question coming up on your screen will be the question number 5 of this exercise. You see, there are so many calculations involved in this. These questions are huge questions. You see? So there is possibility that you might make a mistake. Okay? So, okay. So we are done with this. Now we are going to do the question number 5 of this exercise. You see, this is exercise 8C, and this is our second episode on this. This is Pure Maths 1 course book. Okay, Cambridge International AS and A Levels Mathematics, Pure Mathematics 1. So I'm going to attempt the question number 5 of this exercise. Okay. So here we have a diagram is given to us. Here we have the y-axis, and this is the x-axis, this is the y-axis. Here you have somewhere a point. Okay, this point is Q, this point is R. Okay, this is the P point, this is the O point, this is shaded. I will show you this. Okay, this is equation 3x plus 4y equals to 2y equals to 30. Okay. Listen to this carefully. This is the question number 5 we are talking about. Okay. The diagram shows the graph of 3x plus 2y equals 30. So I wrote the right thing. Okay. OPQR is a rectangle with the area A. The point O is the origin, P lies on the x-axis, R lies on the y-axis. Q has the coordinates of the x, y and lies on the line 3x plus 2y equals 30. Show that the area, that shaded region, is 15x minus 3 by 2x square. Given that the x can vary, find the stationary value of the A and determine its nature. Okay. So this is the question. Let me show you again. This is question number 5. Okay, so let's do the question number 5. So I know the coordinates of the Q. The coordinates of the Q are x, y. Okay, so that means the y coordinate of Q, y, you have 2y plus equals to 30. So 2y will be equals to 30 minus 3x. So y will be equals to 30 minus 3x divided by 6. So the coordinates of the Q are x, 30 minus 3x divided by 2. Okay. So I wrote the y coordinate of the Q in terms of x. So because the Q is on this the line 3x, whose equation is 3x plus 2y equals to 30. So if its x coordinate is x, then the y coordinate will be 2y will be equals to 30 minus 3x, y will be equals to 30 minus 3x divided by 2. So the coordinates of the Q in terms of the x is x, okay. The y will be 30 minus 3x, the whole thing divided by 2. Now, whatever is the x coordinate of the Q, same is the x coordinate of the P. because it's right underneath it and it's on the x-axis, and its y coordinate will be 0. So the coordinate of the P will be x comma 0. The origin 0 comma 0, and the coordinate of the R, it's the the y coordinate will be whatever is the y coordinate of the Q, and its x coordinate will be 0. Okay, so it will be 0 comma 30 minus 3x divided by 2. Okay, so these are the coordinates of the point. The coordinates of the point, the P, Q, and R. It's a rectangle. Okay, that P, Q, O, P, Q, O, P, Q, R. It's a rectangle. So now we have to find the expression for its area, and it means that this thing is x, and this means this thing is 30 minus 3x divided by 2, because its y coordinate is this. Now the area of that is a rectangle. Okay, that shape is a rectangle, so its area is simply length into the width. So the area of the OPQR will be equal to length into the width. The length into the width. Okay, so the area equals to 30x minus 3x square divided by 2. Okay, so this is what we, question number 5a part, this is what we have to prove. Okay, its shape is, they have given this 2 to all of them. So the area will be equals to 30x divided by 2 minus 3x square divided by 2. So the area will be equals to 15x minus 3 by 2 x square. So this is the expression which was already given in the question, and we have to prove that the area is equal to this 5x minus 3 by 2x square. Okay. Now, in their question number 5, in their B part, they say given that x can vary, find the stationary value of A and determine its nature. Okay. So what I will do, I will derivate it. Okay. So A is equals to, the 15x minus 3 by 2 by x square. So we will derivate it. So dA by the dx will be equals to, so its derivation will be 15 minus 3 by 2. The 2 will come on the side, and then you will have x. So the dA by the dx will be equals to 15 minus 3x. So at the stationary point, the dA by the dx will be equals to 0. So I will make 15 minus 3x equals to 0. So 3x will be equals to 15. So x will be equals to 15 by 3. So x will be equals to 5. The nature of this point, we have to find the second derivative. So dA by the dx will be equals to 15 minus 3x. So you take the second derivative, d square A by the dx square will be equal to 0 minus 3x, minus 3. And so d square A by the dx square will be equal to minus 3. So it's a negative number, so it will be a maximum point. Okay, at x equals to 5, we will have the maximum value. And now they said find the stationary value of the A and determine its nature. Okay, now I have to find the value of the A as well at this value of the x. So I write and the area equals to 15x minus 3 by 2 and x square. Just put those values, 15 into minus 3 by 2 into minus 3 and square. So the area will be, then we used our calculator. Okay. So on my calculator, I will write 15 bracket start minus 3 bracket close minus 3 divided by 2 multiply bracket start minus 3 bracket close square and equals to. So area, what's the formula for the area? 15x minus 3 by 2x square. So I put the values. Let me do calculation again. 15 why is negative? Oh, sorry, the x value is 5. The values, I put 3 here. The value of the x is 5. So I have to put 5 here. Sorry. Something is going wrong. Now 15 multiply 5 minus 3 divided by 2 multiply bracket start 5 bracket close square equals to, this is just my answer is coming to be question number 37.5 is the answer, right. So my answer is 37.5 and this is the right answer, sir. This is the x value which I have to substitute here. Okay, so from the book I'm reading the answer. Question number 5a part we have to prove. Okay, we have proved that. Then the B part, the area is 37.5 and it's the maximum area. So this is how you will do the question number 5. At the end, at this point, you see here, this is the value of the x. This is the value of the x which I have to put there in this formula. Okay, so you will find the maximum. Okay, so because you see there are so many calculations involved here, so sometimes we get distracted. But important thing is that you go check your mistake. This is the most important thing in A levels. Okay, so huge question. So I hope you have understood this. This is exercise 8C, and this is our second episode on this exercise. And the main topic of this exercise is practical maximum and minimum problems. The main topic of this chapter is further differentiation. The course we are studying is Pure Maths 1. This is Cambridge International AS and A Levels Mathematics. The code of the subject is 9709. These solutions are related from all the topics. They are about, or you can say from the paper 1 of this subject. Okay, so we are done with the question number 5. So let me erase this. Question number 5. Okay. So let me. So this is the question 5, and this is how you will do this. Okay. Now we are going to do the question number 6. So here I can show you the question number 6 on your screen. You can pause the video if you can. If you will be watching the recording of this, we are going to attempt the question number 6. Okay. Okay. So in the question number 6, we have parabola. So here you have x-axis, here you have y-axis, and here this is the shape. No, it's not the right shape. Okay. Yes. This is P, this is O, this is Q, this is the x-axis. Okay. This is the y-axis. This is the point S. This is the point R. Basically, y is equals to 9 minus x squared. This thing is basically 2p units. Okay. So this is the shape PQRS. Okay. This is the shape given in the question. So the PQRS is a rectangle with 2p units and the area a units. So the length is 2p. The point P and Q lie on the x-axis and the point R and S lie on the curve y equals to 9 minus x squared. Express the PQ express the QR in terms of P. Okay, QR. So the first question is express the QR in terms of P. Okay. So because it's symmetry, so I think this is this side is P, this is P, this is also P. Okay. So the x coordinate of the Q is P and the y coordinate of the Q is 0. Okay. So because R is exactly above this, so the R's x coordinate will be also P. The y coordinate I can find out because this is on this line. The R is on this line or this curve, I mean. So I can find the R's coordinates. So the Q, this is question number 6 I'm doing. Okay, the Q its coordinates will be P comma 0. The R, its x coordinate will be P. So its y coordinate will be 9 minus x square. So y equals to 9 minus p square. So the R, its coordinates will be x comma 9 minus p square. Their question is about find the length of the QR. Their question is find the length of the QR. Okay. So if you want to find out the length of the QR, so the QR length will be equals to this will become P. Okay. The QR length will be P minus P. I can write it here. It will be P minus P whole square plus 0 minus 9 plus P square whole square under root. So this will be 0 square plus this will be P square minus 9 whole square and under root over it. So this will be basically P square minus 9. QR length will be P square minus 9. They say 9 minus P square. Oh yeah, that's 9 minus P square. So you write it, why did I write QR? This minus this. But if I write this minus this minus this, it will become minus. This will become positive. Oh God. So because its y is 0, he just wrote it differently. Okay. He wrote it 9 minus p. Let me do it. So it is basically p minus p. The shape can be matched, no problem, but it will be problem for you to understand this. So you will have 9 minus p square whole square. This is 9 minus p whole square. Okay. So this is the answer which matches with your book. Okay. I changed the order. Okay. From the Q, I subtracted the coordinates of the, from the coordinates of the R, I subtracted the coordinates of the Q. Applied the distance formula, we found that distance is 9 minus p square. When I did the first thing, where I got the answer p square minus 9, but when you have whole square, you can change the order. It will make no problem. Okay. So you have this 9 minus p square is the right answer, sir, for QR. Now, the thing they asked us to do next is show that the area of what? The PQRS is a rectangle. Its area is represented with the A. Show that the area is equals to 2p bracket 9 minus p square. Okay. Now we have to find out the area. That's the B part. The area of the PQRS. So the area of the PQR and S. This is the question. The area is already given. We have to show that this is that area. You know that the area will be the length into the width. It's a rectangle. So I know the length, this length, PQ, and I know this thing. So you simply multiply them. That's the area. So that is length multiplied width. So the area will be, the length is 2p into the A. This is 9 minus p square. So this is the area. Okay. So this is what we have to show. Yeah, that's right. Then we have the C part. He says, find the value of P for which the A has a stationary value. The C part, we have to find the value of P for which the A has a stationary value. Okay, so first of all, we have to derivate this. This is the C part now. This is the B part. This was the A part. Okay. C part, we have to find the value of the, this becomes 18p minus 2p cube. Derivate it, dA by the dp, and that will be equals to 18 minus 2 into 3 into p and its square. So the dA by the dp will be, this will be 18 minus 6 p square. So I derivated that thing. Okay. So the dA by dp, the derivative is 18 minus 6p square. So at the stationary point, dA by the dp should be 0. So 18 minus 6p square will be equals to 0. So it's not square. Yeah, it's square. Yes. So you will have minus 6p square equals to minus 18. So 6p square 18. P square will be equals to 18 divided by the 6. So p square will be equals to 3. So p will be equals to under root 3. And it is plus and minus. Okay. So This is the value of the p. Let me check. Yes, sir. The value of the p is under root 3. So they have only taken the positive value. Okay. Okay. This is the answer, sir. This is the C part. Okay, then we have the D part. In the D part of this question, he says, find this stationary value. Find this stationary value and determine its nature. Okay. So we have to find out the nature of this point. Okay. So I know the first derivative, dA by the dP is equals to how much? So I will find that second derivative, d square A by the dP. That will be equal to 0 minus 6 into 2 into the P. Okay, so this is minus 12P. So at P, and the P equals to under root 3. So the d square A by the dP square, you will have minus 12 into the under root 3, and that is minus 12 under root 3. So this is a negative number, so it will be a maximum point. Okay, maximum point means maximum area. Okay, here it will be at the value of p equals to under root 3. The area will be will have find this stationary value and determine its nature. Okay. So we have to find out that value also. Area is, the here I can find the area. The formula for the area is how much? There you go. 18p minus, it is 2p cube. Okay, so 18. The value of the p is this, under root 3 minus 2 into under root 3 raised to power 3. Okay, so this will be 18 under root 3. This will be so 3 into 2 6. This will become 6 under root 3. So this will become 12 under root 3. And we can find the value of the 12 under root 3. Okay, they have not written the answer in the decimal. They have left it in the third form. So the maximum area will be 12 under root 3. And this will happen when the value of the p is under root 3. You see, when I started this question, in the start, we made a little bit mistake. It's not a mistake actually. The concept is when you take 9 minus p whole square, its whole square, or the p square minus 9 whole square, they both give you the same answer. Okay, but when we took the under root, so then the shape was a little different from the answer given in the book. So then what I did, I subtracted from the coordinates of the r, the coordinates of the q, and then applied the formula of the distance. So this is how you do the question number 6, and I think that's enough for today. In today's episode number 2 on the exercise 8C from the course book of the Pure Maths 1, we have done the question number 4, 5, and 6. And you can see these are huge questions. Lot of calculation is involved. And sometimes what happens, we write some number, mistakenly we write some number way. So the mistakes happens, but you learn from your mistakes, and it's not a big deal. Okay, you should actually learn from them. So I hope that this video will be helpful to you. Please share the link of these videos with your friends who are in AS Math, who have adopted for AS Mathematics, and they are struggling with it. So if their basic maths is, if they will follow this course book, their maths will improve. Okay, for very brilliant students, they don't have to do the course book. They can directly learn from the topicals. So if you find this video useful, if you think that this video and this live session is very useful and it's actually practical, so please like this video, share the link of this video on your Facebook, on your WhatsApp, on your TikTok, wherever it's possible. Share the link of this video with your teacher, with your junior students, and also subscribe my channel, because these are the things which actually support my channel and support me. So thank you very much, everyone. Have a good night. God bless you all.